So picture this elite Olympic snowboarder, right? She's 32 years old, just in absolute peak physical condition.
Oh, yeah. The kind of person who is constantly training and just, pushing her body to the extreme.
Exactly. I mean, outwardly, she is the absolute picture of health.
Yeah.
But when a cellular longevity specialist actually ran a deep panel on her biological age, specifically looking at those protective caps on her DNA, the results were kind of terrifying.
They really were. On a cellular level, her body had the wear and tear of a 56-year-old woman.
Which is wild. Like decades of extreme environmental and physical stress had basically aged her internal hardware by almost 25 years.
Yeah, it's a massive jump.
But here's the craziest part. Over the next 18 months, using a very specific biological protocol, she didn't just stop that rapid aging, she actually reversed it. She brought her cellular age all the way back down to 31.
Which is just, it completely upends the traditional view of aging. We're so conditioned to treat aging as this biological inevitability, right? Just a one-way street of wear and tear.
Right, like a ticking clock.
Exactly. But when you examine the mechanisms inside the cell, you realize that chronological age and biological age are, well, they're two completely separate metrics.
Welcome to this deep dive into the science of longevity. Today, you and I are looking at a stack of sources covering these cutting-edge protocols for peak vitality. We're talking neurophysiology, cellular regeneration, and some wildly advanced metabolic tracking.
Yeah, it's a lot of ground to cover.
It really is. And if you're someone who wants thorough, high-yield knowledge,
Yeah.
but you're just, completely exhausted by the endless sea of wellness influencers and contradictory advice out there, you are in the exact right place. Our mission today is to just cut through all that noise and deliver hard, actionable science directly to you.
And we're going to break down the actual mechanisms behind these protocols, too, because understanding why a protocol works is, well, it's the only way to effectively apply it to your own life.
Absolutely. So we're going to explore how building heavy leg muscle might literally be the most effective way to save your brain from decline. We'll look at why your standard annual blood test is probably giving you a false sense of security, and we will get into the exact DNA-repairing molecules that Olympic snowboarder used to basically turn back the clock.
That's going to be a fun one.
Okay, let's unpack this. Let's start with the largest physical foundation we have. The sources dedicate a massive amount of focus to lower body muscle, basically framing it as the brain's first line of defense.
Yeah, the clinical phrase that keeps popping up in the research is actually, thick thighs save lives.
Wait, really? Like the internet meme?
Like the meme, yeah. But they mean it literally.
But-
And it's not about general fitness or, just taking a brisk walk. Building metabolic resilience starts with the body's largest muscle groups. So
Ah.
the quads, the glutes, the hamstrings.
Okay, so what's the actual protocol here?
The protocol demands progressive lower body resistance training. We're talking heavy squats or the leg press, combined with high-intensity interval training. And you have to push your heart rate up to 90% of its absolute maximum.
Oh, man. I can hear people groaning already, including me. I mean, pushing to 90% max heart rate under a heavy load is brutal.
It's definitely not comfortable.
Right, so why can't I just, go for a nice, moderate 30-minute jog? What is the specific mechanism happening during a heavy squat that a jog just misses?
Well, a jog is great for baseline cardiovascular health, sure, but it doesn't create enough stress to flip a very specific metabolic switch.
A switch.
Yeah. When you contract large muscles under extreme heavy loads, those muscles actually act like endocrine organs. They secrete these signaling molecules called myokines, specifically irisin and interleukin-6.
And according to the sources, these myokines, they don't just stay in the muscle, right? They travel through the bloodstream, and they actually cross the blood-brain barrier.
That's the crucial part, yes.
So it's almost like your quads are firing off a direct text message to your hippocampus, and the text just reads, keep growing.
That is a perfect way to visualize it, honestly. Once those myokines cross into the brain, they trigger the expression of brain-derived neurotrophic factor, or BDNF.
BDNF, for
Yeah. Think of BDNF as a high-powered fertilizer for your brain.
Yeah.
It literally forces the growth of new neurons and fortifies your existing synaptic connections.
That is incredible. And the sources highlight the work of Louise and Nicola, right? She's a neurophysiologist who basically mapped this exact connection.
She did. Her story is fascinating. She was actually a triathlete aiming for Beijing until she had this devastating bike accident in 2011.
Oh, wow.
Yeah, smashed her knees and her ribs. And during her rehab, she ended up working with Usain Bolt's running coach, of all people.
That's a huge pivot.
Right. And he was using EEG scans to map cognitive states during physical performance. So she started noticing that profound physical trauma and recovery were just inextricably linked to neural firing patterns.
Which is what sparked her research into how lower body training directly shields the brain.
Exactly. And what's fascinating here is the specific role of lactate in that shielding process.
Lactate, like lactic acid, the
Right.
stuff that makes your muscles burn.
Yeah, exactly.
Yeah.
When you push to that 90% heart rate, your muscles generate a massive influx of lactate. Now, most people think of it as just a toxic waste product, the stuff that makes you cramp up.
Yeah, I've always thought of it as a bad thing.
Most people do, but the brain doesn't see it that way at all. The brain actually uptakes lactate far more effectively than glucose. It's essentially the brain's preferred hyperclean fuel source.
So you literally have to subject your body to intense, uncomfortable stress just to force the production of this premium brain fuel.
Pretty much, yeah.
And the long-term data on this is just wild to me. There was this 10-year longitudinal study tracking identical twins.
Oh, that study is a classic.
Right. And it proved that the twin who maintained greater baseline leg power over the 10 years actually had significantly thicker gray matter in their brain by the end of the decade compared to their weaker twin.
Which becomes incredibly urgent when you realize that cognitive decline, like the physical shrinking of the hippocampus, it begins in your 30s or 40s.
Wait, that early?
Yeah, that is 20 years before anyone shows outward clinical symptoms of Alzheimer's. So you are building leg muscle today to physically preserve the volume of your brain 2 decades from now.
Okay, so we have this intense physical exertion generating lactate, forcing the brain to grow. But firing all those neurons all day creates a massive buildup of metabolic waste in the brain tissue, right?
Exactly. Like any high-performance engine, it produces a lot of exhaust.
So how does the brain handle the cleanup?
That cleanup happens exclusively during deep sleep, and the protocol the researchers insist upon here is sleep consistency over sleep quantity.
Consistency over quantity, meaning what exactly?
Meaning anchoring your circadian rhythm with the exact same bedtime and wake time, even on the weekends. It also requires stopping all food intake at least 2 to 2.5 hours before bed, keeping the room freezing cold, and wearing a mask to block out all ambient light.
Okay, I want to push back on that a bit because, if I sleep consistently, but my body just naturally wakes up after, say, 5 hours, isn't that fine? Like, can I hack this by just being a fast sleeper?
If we connect this to the bigger picture, you simply cannot hack fluid dynamics.
Fluid dynamics.
Yeah. During deep sleep, your brain activates the glymphatic system, which is essentially a hydraulic plumbing network. Cerebrospinal fluid literally rushes through the brain tissue to physically wash away cellular byproducts.
Okay, washing away the exhaust.
Right. And one of the main byproducts is amyloid-beta, which is a stress protein. The mechanical process of flushing that fluid takes a specific amount of time. If you cut your sleep to 5 hours, the plumbing system just shuts off before the wash cycle is finished.
I love that visual. It's like the glymphatic system is a city street sweeper, right? And it absolutely refuses to come out unless the city is entirely shut down, the lights are off, and there is zero traffic.
That's exactly what it's like.
But if you eat a big meal right before bed, your digestive system is still working. So the traffic is still moving.
Precisely. Digesting food activates your sympathetic nervous system, your fight or flight response. So it keeps your core body temperature elevated and diverts blood flow to your gut, which physically traps you in lighter stages of sleep.
Wow.
And if that street sweeper doesn't run, that leftover amyloid beta, it hardens into plaques. It physically gums up the synapses.
And the sources reference a landmark study in the Proceedings of the National Academy of Sciences showing this, right? That just one single night of restricting sleep to 6 hours causes a significant spike in toxic amyloid beta in the brain.
Just one night.
Yeah. That is terrifying. They also share the cautionary tale of Dr. Florence Comet. She's an endocrinologist who did this incredible self-experiment. She used something called therapeutic plasma exchange to lower her biological age by 15 years. But wait, can you pause and explain what that actually is?
Sure. Therapeutic plasma exchange is this intensive clinical procedure. Basically, your blood is drawn, and the plasma, which is the part that carries all the inflammatory markers and accumulated junk, is filtered out and completely discarded.
It's thrown away.
Yep. And then your red blood cells are returned to your body with fresh, clean fluids. It is quite literally a systemic oil change for your blood.
Okay, so she does this massive, super expensive biological oil change. And she actually drops her biological age by 15 years.
Incredible results, yeah.
But then she decides to build a health app. She starts grinding, sleeping only 4 hours a night for 3 months. And when she retested, that sleep debt completely erased the 15-year age reduction.
Completely wiped it out.
Her biological age rebounded higher than where she started.
It did, because chronic sleep debt drives what researchers are now calling type 3 diabetes in the brain.
Type 3 diabetes.
Yeah, it completely clogs local glucose metabolism. And worse, it triggers your microglial cells. Normally, microglia are the protective defenders of the brain, right? But when they are deprived of sleep clearance, they transform into what researchers call their evil twins.
Evil twins.
Yeah, they become hyperactive and actually start chewing away at your healthy synapses.
Okay, so a strict sleep schedule handles the brain's nightly plumbing. Got it. But what about the rest of the body? A street sweeper in the brain doesn't help clear out the damaged tissue in my liver or my lungs, right? How do we trigger a cleanup system-wide?
That requires dietary and microbial housekeeping. And the primary protocol here is a 5-day fasting-mimicking diet, or FMD.
Fasting-mimicking.
Right. It involves eating a highly specific plant-based diet for 5 days. It's very low in protein and carbohydrates, but high in healthy fats.
Okay, but why not just drink water for 5 days? Why bother with the specialized food at all?
Because strict water fasting causes a massive spike in cortisol and physiological stress. I mean, most people simply can't handle it.
That makes sense. I would be miserable.
Exactly. The fasting-mimicking diet provides essential micronutrients to keep you going, but the macronutrient ratios are engineered to remain entirely invisible to your body's nutrient-sensing pathways. Specifically, these pathways called MTOR and IGF-1.
Okay, MTR and IGF-1, break those down for me. What are they actually doing in the body?
Think of MTOR and IGF-1 as the foremen on a construction site.
Right.
When they sense protein and carbs coming in, they yell, "Hey, we have materials, build new cells, grow." But when you remove the protein and carbs, which is what the FMD does, those foremen go quiet.
Because they think the materials stopped arriving.
Exactly. The body thinks it is starving. And when the body thinks it's starving, it triggers a survival mechanism called autophagy.
Autophagy meaning self-eating, right?
Right. Yes. Your cells realize there are no new building materials coming in from food, so they start scavenging internally. They hunt down damaged mitochondria and misfolded proteins, they break them down, and they recycle them for energy. And the best part is, they do all this while preserving your healthy skeletal muscle.
So what does this all mean? To me, the fasting mimicking diet sounds exactly like putting your computer into safe mode.
Oh, that's a good comparison.
Right. You give it just enough basic power to keep the operating system from crashing, but the system spends its time hunting down and deleting corrupted files rather than opening up new programs.
Yeah, exactly.
And the data from Tim Ferriss is fascinating here. He used to torture himself with these 10-day water fasts. But when he switched to the 5-day FMD, he achieved the exact same drops in his HbA1c levels.
Which is huge.
Yeah. And for you listening, if you aren't familiar, HbA1c is a test that measures your average blood sugar over 3 months by basically looking at how much sugar has physically coated your red blood cells. Dr. Longo ran controlled trials showing 53% of people on the FMD saw massive blood sugar improvements compared to almost zero in the control group.
It's incredibly effective for cellular cleanup, but the sources also emphasize that we have to manage the gut-lung axis to stop systemic inflammation.
The gut-lung axis.
Yeah. The protocol involves using targeted lactobacilli probiotics, like those from a company called Resbiotic, to downregulate 2 major inflammatory pathways, the MMP9 protease and the NLRP3 inflammasome.
Okay, wow, you just dropped some heavy textbook terminology on me. MMP9 protease and NLRP3 inflammasome. That sounds incredibly dense. Walk me through the mechanism of what has actually happened in the gut.
Fair enough. Let's strip away the jargon. Inside your gut, you have all these different populations of bacteria, right? When the bad bacteria called proteobacteria overgrow, they shed toxic debris called endotoxins into your bloodstream. These endotoxins are essentially poison, and they trigger a major alarm system in your immune cells. That alarm system is the NLRP3 inflammasome.
Okay, so the gut bacteria shed toxins, and the immune system just slams the panic button.
Exactly. And when that panic button is pressed, the body unleashes MMP9. MMP9 is an enzyme, but you can really think of it as a rogue demolition crew.
A demolition crew.
Yes. Its job is to break down tissue to allow immune cells to rush into an area. But when it's constantly activated by bad gut bacteria, this demolition crew just runs wild. It starts attacking the collagen scaffolding in your lungs, your joints, and your arteries, leaving behind stiff scar tissue.
Ouch.
Yeah. This is what drives age-related joint pain and arterial stiffening. So the specific lactobacilli probiotics are introduced to secrete molecules that act like site managers. They basically shut down that demolition crew and silence the alarm system.
Okay, that makes so much more sense. And Dave Asprey's story is the perfect case study for this. He grew up in a basement full of toxic mold, which permanently damaged his CCL2 gene.
Right, which left his immune alarm system stuck in the on position.
Exactly. He suffered from severe asthma and joint pain. So to fix it, he attacked it from two sides. He used those targeted probiotics to shut down the MMP9 demolition crew from the inside. But for the scar tissue that was already there in his lungs, he used localized ultrasonic shockwave therapy.
Which is a fascinating physical intervention. Ultrasonic shockwave therapy blasts high-frequency acoustic waves deep down into the tissue, and the physical force of those sound waves literally shatters the hardened, fibrotic collagen. It forces the body to rebuild it smoothly.
That's amazing.
It is. Combining that physical breakdown of scar tissue with the biological shutdown of the inflammation via the gut, it completely resolved his asthma.
Okay, so we've forced the brain to grow with leg power. We've flushed the brain's plumbing with strict sleep. We've deleted corrupted cells with the fasting-mimicking diet. And we've shut down the inflammatory demolition crews via the gut. That is a ton of optimization.
That's a lot, yeah.
But eventually, every cell hits a hard biological limit on how many times it can divide before it just dies, right?
You're referring to the Hayflick limit?
Yes.
Yeah, every time a cell divides, the protective caps on the ends of its chromosomes, the telomeres, they get a little bit shorter. Think of them like the plastic tips on the ends of your shoelaces.
Right.
Once those tips wear down completely, the shoelace frays, the DNA becomes unstable, and the cell can no longer divide. It enters senescence.
So to truly push longevity past that, we have to travel inside the nucleus of the cell itself and stop those shoelaces from fraying.
And that is exactly where programmed cycling of peptide bioregulators comes in. The protocol involves taking extracts from the pineal gland, called epitalon, and extracts from the thymus gland, called thymolin. And you cycle these for 10 to 20 days every few months.
Now, here's where it gets really interesting, because the moment you say the word peptides, everyone immediately thinks of Ozempic for weight loss, or maybe like BPC 157 for healing a torn tendon. But the sources make a massive, fundamental distinction between those popular peptides and these bioregulators. What is the difference at the cellular level?
Well, the difference is where they operate. I mean, popular synthetic peptides like Ozempic, they operate on the outside of the cell.
Oh.
They bind to surface receptors and basically ring a doorbell to trigger a reaction inside. But peptide bioregulators are completely different. They are natural, ultra-short chains of just 2 to 4 amino acids.
Very small.
Unbelievably small. Because they're so small, they don't ring the doorbell. They slip right through the cell membrane, pass through the nuclear envelope, and they bind directly to your DNA.
Wait, they bind directly to the DNA?
Yes, they physically bind to tightly coiled DNA, which is called chromatin, and they force it to unwind. This exposes specific genes, activating the production of an enzyme called telomerase.
And what does telomerase do?
Telomerase is the biological machine that rebuilds the plastic tips on your shoelaces. It elongates the telomeres. Clinical trials show this process can actually extend the Hayflick limit, the absolute threshold of cellular life, by roughly 40%.
A 40% extension in cellular lifespan. That is incredible. And that brings us right back to our snowboarder from the beginning, Tori Wright. Her telomeres were frayed down to the length of a 56-year-old. But by using this specific peptide bioregulator protocol under Dr. Bill Lawrence's supervision, she activated that telomerase and rebuilt her chromosome end caps back to her true age of 31.
It's phenomenal, and Dr. Lawrence even did it on himself. He reversed his telomere age from 75 all the way down to 23.
That sounds like science fiction.
I know. We also have that legendary 12-year trial by Professor Vladimir Kavinson in a nursing home. The elderly residents who were given the pineal peptide saw their mortality rate drop by half, and those who took the thymus peptide saw their 6-year mortality rate plummet from 82% down to just 33%.
Wow. It is profound evidence that cellular aging is malleable. But there is a catch. If you are going to subject yourself to heavy squats, strict sleep schedules, fasting diets, probiotics, and, DNA-altering peptides, you cannot fly blind. You need to know if the interventions are actually working inside your own body.
Right. You definitely need a map.
And according to the sources, relying on your standard once-a-year blood test at your doctor's office is a terrible strategy for this. Why are those standard reference ranges lying to us?
Because standard reference ranges are graded on a curve, and the curve is failing. They basically average out the blood work of an increasingly sick, metabolically dysfunctional population.
So normal doesn't mean healthy.
Exactly. For example, by the time your standard blood test flags your fasting glucose as clinically high, you've likely already suffered silent damage for a decade. And you may have permanently lost 50% of your pancreas's ability to produce insulin. You're catching the disaster after it's already happened.
It's like checking your bank account balance only once a year. You log in, realize you are completely broke, and panic, but you have no idea where the money went or when you lost it.
Great analogy.
The protocol here demands real-time notifications. It requires testing your blood every 3 months to map your personal direction of travel. And specifically, it calls for a test called the MVX, or the Metabolic Vulnerability Index, using NMR spectroscopy.
Right. NMR spectroscopy uses magnetic fields and radio waves to look at the exact size and number of particles in your blood. And the origin story of how this test was developed is actually this amazing accident in medical history.
Oh yeah, tell that story.
So in 1986, the New England Journal of Medicine published this massive paper claiming that this NMR machine could detect cancer in blood plasma. But a biophysical chemist named Jim Otvos was skeptical. He took leftover blood plasma from perfectly healthy women who had just given birth, ran it through his NMR machine, and the machine lit up with massive false positives for cancer.
So the New England Journal of Medicine just got it wrong. What was the machine actually looking at?
Otvos realized the original researchers had completely misidentified the molecular signal. The machine wasn't detecting cancer tumors at all. The magnetic peaks were actually detecting the tiny methyl groups on lipids fats trapped inside different-sized protein packages in the blood.
Okay, wait.
We know these packages as VLDL, LDL, and HDL cholesterol.
Oh.
Yeah. That serendipitous mistake led Otvos to invent the modern LDL particle test, which eventually evolved into the MVX score.
So what does the MVX score actually measure to predict my direction of travel?
It measures 3 incredibly specific metabolic markers. First is glycate. This measures systemic inflammation by basically looking at how many sugar molecules are stuck to your immune proteins.
Okay.
It tells you if your body is in a state of chronic low-grade panic. Second, it measures the physical number of small HDL particles, which is a direct window into the health of your blood vessels. And third, it measures your levels of citrate and branched-chain amino acids.
And what do those last two tell us?
If those last two are chronically low, it is a glaring red flag for metabolic malnutrition and impending muscle loss, or sarcopenia.
And the predictive power of this MVX score is terrifyingly accurate. Duke University ran a 7,000-patient study on people with heart issues. They found that 60% of the deaths in that group were not actually caused by heart attacks. They were driven by metabolic wasting, which the MVX perfectly predicted.
Yeah, the data is undeniable.
Even crazier, a 35-year longitudinal study proved that your MVX score is entirely independent of your birthday. Like a 30-year-old and a 60-year-old can have the exact same score. The test spots biological frailty decades before any clinical symptoms appear.
This raises an important question for you, our listener, to consider. How are you measuring your health? Are you waiting for a clinical diagnosis to tell you the bank account is empty? Or are you tracking the exact molecular direction of travel of your biology?
That is the real question. So to bring this entire deep dive together for you, achieving peak vitality is about stacking these precise biological mechanisms. It's building leg power to force lactate and BDNF into the brain. It's anchoring your sleep to let the glymphatic system flush out the amyloid plaques. It's using fasting diets and targeted probiotics to delete corrupted cells and shut down the demolition crews in your gut. It's cycling tiny peptides to travel inside the nucleus and rebuild your DNA. And it's tracking every single step of that with the MVX.
And here is a final thought to leave you with today. If the Hayflick limit of cellular division can be extended by 40%, and if biological age can be so drastically separated from your chronological birthday, as we saw with the snowboarders' telomeres and the MVX scores, then aging is no longer an inevitable timeline that you are strapped to.
Right.
It implies that aging, to a very significant degree, is simply an engineering problem. And as we've explored today, it is a problem we are already learning how to program.
So the next time you think about your long-term health, don't look at the broken, inevitable model of aging. Look at the engineering schematics you now have at your disposal to change your direction of travel. Thank you for joining us on this exploration. We'll see you next time.